So this is obviously going to be a fun day, but let's start here. How do biologists classify organisms?
All right, so this unit is about human anatomy and physiology, but I feel like it's really important to figure out, well, where do humans fit in the grand scheme of things?
Okay.
So we take a look at classification. We'll look at taxonomy, which is the study of classification, and see how scientists are going to organize organisms into different groups. And this is really interesting because when I was in school, we learned about the 5 kingdoms. We've got you're either a plant, you're an animal, you're a protist, you're bacteria, or you're a fungi. And I don't mean like a fun person like mushrooms. Okay. So, but then years later I was teaching and now it became the 6 kingdoms. So they included also archaebacteria. Nowadays, they actually will classify into 3 major domains. So you're either a eukaryote, which has a nucleus, has membrane-bound organelles, or you're bacteria, or you're archaebacteria. Then those groups can get even more specialized, and that's where you see the kingdom, phylum, class, order, family, genus, species. When we do that, we'll kind of look at, okay, well, how are organisms related? And then also how do scientists name organisms using dichotomous keys, which are a lot of fun. But ultimately, we're going to get to human anatomy and physiology.
So what's the difference between human anatomy and physiology?
All right, so anatomy is more of like the form or the structure, whereas physiology is what it does or how it does its job, how it functions. So let's take a look at like this heart here. If we take a look at the heart, we can see the muscle on the outside. We can open it up and see that there's 4 chambers. We see that there's the bottom chambers. Some are thicker than others. But when you take a look at the actual form, you're looking at the structure itself.
Right.
Physiology would more be like, how does blood flow through this heart? Well, we're going to find out that blood always flows through the right side first. That's your right rotten side. That is the deoxygenated blood. That's why I call it right rotten. It'll come through the right atrium, go down to the right ventricle, then go out to the lungs to pick up the oxygen it needs. Then it comes back through the left side, goes down to the left ventricle, and then out of the heart. So the heart is like the gatekeeper to the lungs. Okay? So that would be more of the physiology.
Right.
If we take a look at this fun thing here, you want to hold this?
Of course.
Yeah. That's a cow bladder.
Excellent.
Awesome, right? So you can see the little nubs at the top are where they
Yes.
were actually connected to tubes called the ureters. And we can look at the structure of that bladder. Or we can look at how urine would flow through that bladder and be stored in that bladder. And the bladder would expand, and that would be more of that physiology or the function.
Cool. This is what I wanted to do this morning when I woke up, is hold a cow bladder. All
Nice.
right. So let's see. How does the human body systems, how do they coordinate to maintain homeostasis?
Right. So homeostasis was that big word that I said we're going to talk about all year, and this is kind of bringing it to a close.
Yeah.
Our body systems need to work together, because if they don't and we can't maintain like the body temperature or the glucose levels, you would get sick or you would die. So they have to coordinate. So we're going to do a fun little activity to see how our body maintains homeostasis. You ready for this,
I'm ready
Mr.
for
Barber?
this. Yes.
All right. So here I have ice water.
Yep.
And what I'm going to ask you to do is you're going to just stick the tip of your face into that ice water as long as you can. If you have to come up and take a breath, just go back down. Before you do that,
Okay.
I've actually got a heart monitor on you.
Yes.
So we're going to take your heart rate, which is, looks like it's about 75. What it's reading. All right, so we've got your heart rate about 78. I think he's getting nervous.
Okay.
All right. When I say you're going to put your face in, and I'm going to be watching the heart rate. Oh, yeah, we're at 79. You're going to put your face in, and then we're going to see what happens. So
Okay.
you ready for this?
Let's go.
All right, go. So we're down to 77, 70, 65, 63, 58. Excellent. 56. So
Sweet.
your heart rate went from 79, now it's at 53, to 53 in that time that you were in that water.
Awesome.
Why do you think it would have done that? Think about.
I think I'm trying to conserve oxygen because I'm holding my breath.
Awesome. So you are holding your breath. You're trying to conserve that oxygen. So what the body does to maintain homeostasis is it's going to lower that heart rate so that you're not using as much oxygen. Now, what would happen if you stayed even longer is that there's something called, this is called the diver's response. If you were to stay immersed longer, your body would go through something called peripheral vasoconstriction. So let's break that down because that's kind of a crazy word there. Peripheral.
Like peripheral vision on the side.
Perfect. Peripheral to the side. Vaso is going to be dealing with the vessels. Constriction.
Tightening,
like a boa constrictor is going to squeeze. So your vessels to the side of your body, to your extremities, are going to tighten. And what that does is it's going to let less blood go into those directions to conserve the amount of blood going to your heart and your brain, your vital organs. So your body automatically has this reflex that's going to allow it to maintain its homeostasis, which is pretty incredible.
That is cool.
Interestingly, a lot of times so basically the reason this happens is your face has these nerve receptors in it. And that's going to take in the reading, okay, we're under cold water, and that's going to trigger all of this to happen. A lot of that will also actually bring down your arousal state. So sometimes when people are really stressed out, they'll say, oh, go put some cold water on your face. The reason that works is because the cold water is going to those receptors. So you can actually just take a wet, cold towel and put it right over here under your eyes, and it would do the same thing.
So your whole body is reacting as if you're all underwater just because of, is that part of what you're saying?
Exactly.
That's pretty interesting.
Exactly. And your body does this every day. It's constantly maintaining that stable internal environment to keep you healthy.
Cool.